Alright, I'm doing Teach the Dog chapter 4. So this one says write the complete ionic equation and net ionic equation for the following molecular equation. Alright, so I found how many of each element, the net equation. So basically I added like aqueous, solid, what was precipitated. I looked at the chart for that of like how the elements, if they're soluble or insoluble, and I went from there. So from the ionic equation, I have to separate the aqueous molecules apart. So K, 6K aqueous plus 2 PO4 aqueous plus 3 Fe aqueous plus 6 Br aqueous yields 6K aqueous plus 6 Br aqueous plus Fe3PO4 subscript 2 solid. This one you can leave alone because it's a solid, because what we're going to deal with are the aqueous ones. So the ones that match on the reactant sides and what matches on the product sides, I cross them out. The ones that are matchy are spectator ions. They basically don't do anything, quote unquote, or at least like chemistry wise, like what we want are the ones that don't match. So then that what's going to equal our net ionic equation, 2PO4 aqueous plus 3Fe aqueous yields Fe3PO4 subscript 2 solid. Okay, and then what's soluble, not soluble? So this one is not soluble, BaSO4, because Ba is insoluble. It won't associate. It's also part of the sulfate soluble list of exceptions, because there's like a list. Na3PO4 soluble. AgCl is not soluble because silver is not is insoluble because of the strong ionic bonds. It's not easily disrupted by water. And then KOH and CuNO3 nitrate ions generally are soluble, except the exceptions, which are silver, PbHg. There's also a soluble list too, so you can like look down, match, and whatnot if you want to double check. So show how cations and anions could swap in a double displacement reaction. All right. So I use the inside with inside, outside with outside rule. So NO3 would react with Ba, and NO3 is a negative, Ba is a positive, so I have to match, I have to balance that out. Ag silver plus 1 Cl, like just one atom of Cl is -1, so those balance out, except this one has 2 Cl atoms and this one only has 1 silver atom. Therefore, I balance it out. Let's see, so I balance the equation, so it's actually 2 silver, so 2 AgCl2 solid, plus BaNO3 subscript 2, and I put the 2 there because it has to balance out the charges, because NO3 equals -1 and Ba equals 2 positive charge, so you have to balance it out, which is what I did. All right, so mole to mole conversion. So what I did was I had to balance the equation first. So what I did was I write down what each like element had. So carbon was 1, hydrogen was 4, oxygen was 3, and whatnot. Carbon was 1, hydrogen was 2, oxygen was 3, but I had to make the match. So then with the new coefficients, they're now 2, 8, 6, 2, 8, 6. So then they're balanced, they're happy. And I did the conversion of the, what is it, reactant and the product. So I did CH3OH, I did 2 moles because that's the coefficient, 2 moles times, was it 1 mole, and this is the molecular mass of CH3OH. Did that times 2 moles of CH3OH with 2 moles of CO2 on top. And how I did that was I did the molar ratio, so 2 and 2 right there equals 4/256, which equals 0.016 moles of CO2. All right, so this one, let's see, this one is basically a conversion of like mole of substance A to mole of substance B. So convert 3.56 of CH3OH to number of O2 moles. So I did what we start off with, what I was given, 3.56 moles of CH3OH. I used the molar ratio, 2 moles of oxygen over 2 moles of CH3OH. How I did that was I went back, I looked at the equation right here, the balance equation, equals 5.34 moles of oxygen. And I basically did the same with question number 5. It's a mole A to mole B ratio. So this one is 15 because I got 15 moles of O2 right here to completely react with with water. So this is 15 moles of oxygen over 1, and this is the molar ratio again of the balance equation that we did. So multiply that across, equals 20 moles of H2O. All right, and then let's see for this one. Okay, so I'm looking for the the actual and the theoretical yield. So with BR, so what I did was BR 95 right here grams over the molar mass of BR right there, which is already given, equals 0.594 moles. I have to times that by 100, equals 59.4 grams, and that's the theoretical yield. And then to find the percentage yield, I took actual over theoretical. The actual, because it says gave us 55.5 grams, so 55.5 over 59.4, which is the theoretical, times it by 100, which equals 93.4%, which is the yield. Okay, yep, that's it.